Chapter 12, The Forgotten Spaces. The comforting embrace of a soft blanket on a cold evening. The soul-stirring memory triggered by a familiar scent wafting from a bakery. The subtle shift in your thinking as a room grows too warm. These experiences reflect the profound influence of what we might call the forgotten senses. Touch, smell, and temperature perception that shape your psychological reality with remarkable power despite receiving far less attention than sight and sound in our visually dominated culture. While we dedicate considerable resources to the visual and acoustic qualities of our environments, these other sensory dimensions often operate in the background of awareness, unacknowledged yet continuously influencing mood, memory, cognitive function, and emotional well-being through pathways both ancient and intimate. These sensory experiences speak to some of the most primitive and emotionally resonant areas of your brain, creating effects that can transcend conscious thought while profoundly shaping your experience of being in the world. In this chapter, we'll explore these often overlooked sensory dimensions, examining how olfactory experiences influence your emotional state and memory function, discovering how tactile elements create fundamental psychological security, understanding temperature's surprising effects on cognition and social perception, and learning principles for creating environments that nourish your complete sensory being rather than merely addressing sight and sound while neglecting these equally essential aspects of experience. Olfactory influences on mood and memory. Among all sensory systems, your sense of smell maintains perhaps the most direct connection to brain regions processing emotion and memory, creating psychological effects that often operate with remarkable immediacy and power compared to other sensory pathways. The neurological uniqueness of smell olfaction, your sense of smell, follows neural pathways fundamentally different from your other senses, creating distinctive psychological effects through its unusual processing architecture and direct connections to emotional and memory systems in your brain. What makes smell neurologically unique is its direct connection to the limbic system, the brain region involved in emotion processing and memory formation. Unlike other sensory information that passes through the thalamus, a sort of sensory relay station, before reaching the cortex, olfactory signals travel directly to limbic structures including the amygdala and hippocampus. This direct pathway creates what scientists refer to as privileged access to emotional and memory systems, Hertz, 2016. Brain imaging studies confirm these distinctive connections. When exposed to odors, our brains activate regions involved in emotion and memory processing more directly and rapidly than with other sensory stimuli. Arshamian et al., 2018. This architectural difference helps explain why scents often trigger emotional responses before we've even consciously identified what we're smelling. The evolutionary origins of this unique arrangement likely reflect olfaction's ancient role in survival. Smell was one of the earliest senses to evolve, helping organisms detect food, predators, and potential mates long before complex visual systems developed. This evolutionary history created a sensory system wired directly into brain regions governing our most fundamental responses. Perhaps most interestingly, these neural pathways create a sensory experience that differs qualitatively from our other senses. Smell's direct limbic connections mean that olfactory experiences are inherently emotional in a way that visual or auditory stimuli are not. This emotional primacy makes smell particularly powerful for influencing psychological state, even when we're not consciously focusing on olfactory information. Emotional aromatics. How scents shape mood. Beyond smell's general neurological characteristics, specific scents influence emotional states through both innate biological pathways and powerful learned associations that collectively shape your psychological responses to different olfactory experiences. Research suggests that certain scent categories demonstrate consistent emotional effects across diverse populations. Lavender, for instance, has shown stress-reducing properties in multiple experimental studies. Several controlled investigations have found that lavender aromatherapy can reduce psychological stress markers compared to control conditions. Though the magnitude of these effects varies across studies, Sanchez-Vidania et al. 2017. Similarly, citrus scents appear to have mood-elevating properties, with studies showing reduced anxiety and improved mood in medical settings following citrus oil exposure, Lerner et al., 2005. These physiological effects appear to involve complex biochemical mechanisms, rather than merely psychological expectations. Scientific reviews have found evidence that certain essential oils contain compounds that may influence neurotransmitter systems involved in mood regulation, though researchers emphasize that this area requires further investigation with larger sample sizes and more rigorous methodologies. Ali et al., 2015. Beyond these potential direct effects, scents create powerful emotional responses through what scientists call associative learning mechanisms, the process whereby initially neutral odors become connected to emotional experiences through repeated pairing. This conditioning process can establish lasting connections between specific scents and emotional states, explaining why a perfume might trigger nostalgia or why a hospital smell might evoke anxiety. What makes these emotional associations particularly potent is their stability over time. Research on olfactory memory has found that scent emotion associations often persist for years with minimal diminishment, demonstrating remarkable resistance to extinction compared to associations formed through other sensory pathways, Hertz 2016. This persistence helps explain why childhood scent memories can retain such emotional power decades later. The practical applications of these emotional effects have been studied in various contexts. In retail environments, appropriate ambient scents have been found to increase customer satisfaction and time spent shopping, Spangenberg et al., 2006. In healthcare, analysis of multiple studies suggests that aromatherapy shows promise for anxiety reduction in certain clinical situations, though more rigorous research is still needed, Kiecolt-Glaser et al., 2008. These findings collectively suggest that olfactory stimuli represent an underutilized dimension for enhancing psychological well-being in environmental design. Anthropological examinations of smell across cultures show that our modern emphasis on visual and acoustic design often neglects this powerful sensory channel that directly influences emotional experience. The scent memory connection. Among smell's most remarkable psychological effects is its distinctive relationship with memory, a connection qualitatively different from other sensory memory relationships through both its emotional intensity and its ability to retrieve otherwise inaccessible autobiographical memories. This phenomenon, sometimes called the Proust effect after the famous literary description in Remembrance of Things Past, has been scientifically validated through multiple studies. Research by Hertz and colleagues, 2004, has demonstrated that memories evoked by odors are often more emotional and associated with stronger feelings of being brought back to the original event compared to memories triggered by other sensory cues. What makes these scent-evoked memories so distinctive? Studies have found that odor-evoked autobiographical memories tend to be older, more emotional, and less frequently thought about than memories evoked by verbal or visual cues, Willander-Larson, 2007. This suggests that smell may access memory traces that remain relatively protected from the memory distortions that typically occur through frequent retrieval and retelling. The neural basis for these distinctive memory effects has been investigated using brain imaging techniques. Research has demonstrated that odor-evoked autobiographical memories activate the amygdala and hippocampus more strongly than memories triggered by the same events, but cued with words, Arshamian et al., 2013. This heightened activation of emotion and memory regions helps explain the phenomenological distinctiveness of scent-evoked memories. Perhaps most intriguingly, smells sometimes retrieve memories that cannot be accessed through other retrieval cues. Studies have documented that odors can trigger recall of experiences that people cannot access when provided with visual or verbal prompts related to the same events. Goddard et al., 2005. This unique retrieval capacity suggests that olfactory information may establish distinctive memory pathways that remain accessible when other retrieval systems fail. These memory effects create significant opportunities for both therapeutic applications and environmental design. Clinical researchers have begun exploring olfactory stimulation for memory support in conditions like Alzheimer's disease, finding that familiar scents can sometimes trigger autobiographical memories even when other retrieval methods fail, Glaché-El-Haj, 2020. In environmental design, these effects suggest the value of thoughtful scent integration to enhance place attachment and create distinctive environmental identities. Experts in odor sensation and memory conclude that smell's unique relationship with autobiographical memory represents one of the most powerful yet underutilized psychological resources for supporting well-being through environmental design. This connection offers opportunities for creating spaces that not only meet functional needs but also support deeper psychological processes relating to identity, continuity, and emotional regulation. Creating beneficial olfactory environments. Understanding smell's psychological influences allows more conscious creation of olfactory environments that actively support well-being through both scent selection and implementation approaches aligned with specific psychological intentions. Research suggests several evidence-based approaches to beneficial olfactory design. Contextual calibration involves selecting scents aligned with specific activity needs. Sensory research on cross-modal correspondence, alignment between different sensory channels, including olfactory elements, suggests that environments supporting focused work might benefit from scents like rosemary, which has been associated with improved memory performance in controlled studies. Moss et al. At 2003, while relaxation spaces might incorporate lavender, which has been associated with parasympathetic activation in some experimental research. Coulevant et al. 2013. Implementation subtlety represents another crucial consideration. Studies on consumer perception have found that scent intensity significantly influences acceptance and perceived pleasantness, with moderate or subtle intensities typically preferred over stronger presentations. Spangenberg et al. 2006. These findings align with research suggesting that lower-intensity scent presentations often create more positive psychological effects than stronger alternatives that may trigger sensory adaptation or irritation. Individual variation requires particular attention in olfactory design. Studies of olfactory genetics have documented that smell sensitivity varies substantially between individuals due to genetic factors. Mainland et al. 2014. Additionally, personal associations with scents create highly individualized response patterns based on past experiences. These variations highlight the importance of providing options, rather than imposing uniform scent conditions, regardless of individual differences. In practical implementation, several strategies have shown promise. Microencapsulation technologies that release scents gradually rather than continuously have proven effective in controlled studies. Creating distinct scent zones rather than uniform conditions throughout environments allows for more personalized experiences. And providing personal control over scent exposure whenever possible respects individual differences in sensitivity and preference. Experts in urban sensory design argue that olfactory elements represent one of the most underutilized dimensions in creating psychologically supportive environments. By approaching scent as a functional environmental element rather than merely an aesthetic enhancement, environments can better support fundamental psychological processes relating to emotion, memory, and overall well-being. Tactile elements in psychological comfort. Beyond sight, sound, and smell, your sense of touch creates foundational psychological experiences through pathways that begin developing before birth and continue influencing well-being throughout your entire life. Touch represents perhaps the most emotionally significant sensory system for psychological security, creating effects that operate at levels both conscious and deeply implicit in shaping how safe, connected, and grounded you feel within your environments. The security foundations of touch-touch processing begins earlier in development than any other sensory system and establishes foundational patterns for how you experience security, comfort, and distress throughout your lifetime. The developmental importance of touch has been established through decades of research. Beginning with landmark studies on infant monkeys by Harlow in the 1950s, researchers have documented how tactile experiences fundamentally shape developing nervous systems. Subsequent work has shown that appropriate touch stimulation influences everything from stress hormone regulation to immune function to emotional development in human infants. Field, 2014. These early touch experiences create what developmental scientists refer to as embodied security templates, neurological patterns that shape how physical contact influences your sense of safety throughout life. These early tactile experiences lay the groundwork for how all subsequent touch will be experienced and interpreted on both conscious and unconscious levels. The neurological basis for these touch effects involves what scientists call the interoceptive system, neural pathways processing internal bodily sensations that significantly influence emotional state. Research has demonstrated that specific touch receptors called C-tactile afferents respond preferentially to gentle stroking touch at skin temperature, triggering parasympathetic activation associated with calming and soothing. McGlone et al. 2014. These specialized receptors appear to form a touch system specifically evolved for social and emotional communication, rather than merely discriminative touch. Deep pressure stimulation represents another important tactile pathway. Studies have documented that firm, distributed pressure across the body appears to increase serotonin production while reducing cortisol levels in some individuals, particularly those with sensory processing difficulties or anxiety disorders. Chen et al. 2013. These pressure effects operate through different neural pathways than light touch, activating deep mechanoreceptors that signal security through gentle containment rather than threat through constriction. These touch mechanisms begin influencing psychological security long before conscious cognitive development. Research on kangaroo care for premature infants has demonstrated that appropriate tactile stimulation regulates fundamental physiological processes even in neurologically immature organisms. This regulation creates what neurodevelopmental researchers call neurobiological security foundations that continue influencing responses to environments throughout life. Material intelligence. How surfaces affect psychology. Beyond pressure patterns, the specific materials you touch throughout your environments create significant psychological effects through both sensory properties and learned associations that collectively influence comfort, security, and environmental engagement. Natural materials appear to create distinctive psychological benefits compared to synthetic alternatives, even when visually similar. Research has found that touching wood surfaces reduced sympathetic nervous system activation compared to touching visually similar plastic or metal surfaces. Ike et al. 2017. Similar work has demonstrated that contact with wood elicits physiological relaxation based on measurements of heart rate variability and blood pressure, suggesting that natural material interaction creates measurable calming effects beyond subjective preference. Temperature characteristics significantly influence tactile comfort through both objective thermal properties and psychological expectations. Pioneering work on thermal comfort has shown that materials with lower thermal conductivity, like wood, feel warmer than high-conductivity materials, like metal, even at identical temperatures. Bergman T.S. 2010. This perceived warmth contributes to what environmental psychologists call psychological warmth, feelings of comfort and welcome that extend beyond mere physical temperature to influence overall environmental experience. Texture diversity appears to provide what sensory researchers describe as tactile nourishment, appropriate stimulation of diverse touch receptors through varied surface characteristics. Studies have demonstrated that people generally prefer moderate texture complexity over either extremely smooth or extremely rough surfaces. Etsy et al. 2014. This preference likely reflects what sensory scientists call optimal stimulation levels, sensory input that provides sufficient information to engage without overwhelming tactile processing systems. The psychological importance of these material effects appears particularly pronounced for what architects call high-contact surfaces, elements touched frequently or for extended durations during environmental use. Doorknobs, handrails, seating surfaces, and other regularly contacted elements create disproportionate influence on environmental experience, despite often receiving less design attention than more visually prominent but rarely touched features. These material effects highlight what haptic researchers call the experiential dimension of materials, the reality that material choices create not just visual or functional effects but actual psychological experiences through their tactile properties. Environmental designers must consider not just how materials look, but how they feel when creating psychologically supportive environments. The comfort-security connection. Touch creates perhaps its most profound psychological effects through the powerful connection between certain tactile experiences and fundamental feelings of safety, belonging, and grounding that support overall psychological well-being. Research on deep pressure interventions demonstrates this security connection. Studies have found that appropriate pressure applications reduced anxiety, stereotypic behaviors, and hyperactivity in various populations, particularly individuals with autism spectrum conditions and anxiety disorders. Chen et al. 2019. Research on weighted blankets has found improved sleep quality and reduced anxiety in controlled studies with both clinical and non-clinical populations. Aaron et al. 2020. While physiological research has documented how deep pressure stimulation activated parasympathetic responses associated with relaxation and security. These security effects appear to operate through what neuroscientists call interoceptive feedback loops, systems connecting peripheral sensory information with central emotion processing regions. Neuroscience research has mapped how certain touch sensations travel through dedicated pathways to the insular cortex, a brain region involved in processing emotional salience and bodily states. McGlone et al. 2014. This direct connection helps explain why certain tactile experiences create such immediate and profound feelings of security or distress. Tactile predictability, whether touch experiences align with expectations, significantly influences security feelings. Studies on sensory processing have found that unexpected tactile experiences often trigger defensive responses and heightened vigilance, while predictable touch typically supports greater environmental comfort. This research suggests that environments with high tactile predictability, where surfaces feel as they visually appear they should feel, support greater psychological security through what sensory integration researchers call cross-modal congruence. Appropriate resilience in supporting surfaces creates security through what ergonomic researchers call stability confidence, the often unconscious assurance that materials will reliably support your body. Studies on seating comfort have documented that surfaces that provide appropriate resistance without excessive hardness or softness create optimal support perceptions. This balanced resilience supports what embodiment researchers call background body confidence, the typically unconscious but fundamentally important sense that your physical position remains secure without requiring ongoing monitoring. These security effects explain the psychological power of certain tactical interventions like weighted blankets. Reviews of multiple studies have found that appropriate weight application, typically around 10% of body weight, can reduce anxiety and improve sleep quality across diverse populations, Iran et al. 2020. Similar benefits appear in studies on deep pressure vests and therapeutic swaddling, highlighting touch's remarkable capacity to influence fundamental aspects of psychological security through direct physical pathways. Creating tactile well-being. Understanding touch's psychological influences allows more conscious creation of environments that actively support well-being through tactile elements aligned with human comfort and security needs. Research supports several evidence-based approaches to tactile well-being design. Interaction mapping involves systematically identifying all body environment contact points that occur during normal use. This approach builds on work by Hassanzal and colleagues, 2013, on designing meaningful interactions, focusing specifically on tactile contact. By identifying high-frequency contact points, designers can prioritize tactile quality where it creates the most significant psychological impact rather than distributing attention equally across all surfaces, regardless of interaction frequency. Material authenticity represents another crucial consideration. Studies have demonstrated that congruence between visual appearance and tactile reality significantly influences material experience. Materials that deliver tactile experiences aligned with their visual promises create what sensory researchers call perceptual confirmation, the satisfaction of having sensory expectations met rather than contradicted. This confirmation supports greater environmental comfort through reduced cognitive dissonance between different sensory channels. Progressive comfort strategies address changing comfort needs during extended environmental occupation. Research has found that comfort perceptions change significantly over time, with surfaces that feel initially appropriate, sometimes creating discomfort during prolonged use. This temporal variation suggests the value of layered material strategies combining structural integrity with appropriate tactile surfacing, providing comfort during both initial and extended interactions. Practical implementation approaches include what material scientists call human-centered material selection, choosing materials based on their experiential qualities rather than merely technical specifications. Designers must consider not just physical properties but the psychological meanings and responses materials evoke. This approach transforms material selection from technical specification to experiential design, creating environments that support psychological well-being through their tactile qualities. Experts in multisensory architecture conclude that touch represents a fundamental but frequently overlooked dimension of environmental experience. By bringing greater consciousness to this silent sense, environments can better support fundamental psychological needs relating to security, comfort, and embodied well-being. Temperature perception and emotional states. Beyond mechanical touch sensations, your perception of temperature creates profound psychological effects through pathways connecting thermal experience to emotional processing, social perception, and even fundamental aspects of decision-making and judgment. The temperature-emotion connection. Temperature perception maintains remarkable connections to emotional experience through both metaphorical relationships and direct physiological pathways that collectively create significant psychological effects. Some of the most compelling evidence for these connections comes from embodied cognition research. In a groundbreaking study, Williams and Barg, 2008, found that briefly holding a warm versus cold beverage influenced how participants subsequently judged the interpersonal warmth of a target person. Participants holding warm drinks rated the same individual as having a warmer personality, more generous and caring, compared to those holding cold drinks, without any awareness of this influence. This finding demonstrated what researchers call embodied metaphorical mapping, physical experiences activating associated conceptual frameworks. These effects appear to operate through shared neural substrates. Brain imaging research has found that experiencing physical warmth activated insular cortex regions also involved in processing social warmth and trust. Inagaki-Eisenberger, 2013. This processing overlap helps explain why thermal and emotional experiences demonstrate such strong cross-domain influences. As cognitive scientists argue, these connections aren't merely linguistic, but reflect actual neural sharing between sensory and conceptual processing. The psychological significance of these connections likely reflects temperature's fundamental role in early developmental experiences. Physical warmth consistently pairs with caregiving, nurturance, and security throughout infancy. These repeated pairings create what developmental psychologists call primary metaphors, direct associations between physical sensations and emotional concepts that remain active throughout adulthood. Experimental studies continue to document these temperature-emotion connections. Research has found that room temperature influenced social proximity preferences, with slightly warmer rooms, approximately 75 degrees versus 68 degrees. 20s, decreasing perceived social distance and increasing feelings of relational closeness. Zimmerman-Semen, 2009. Similar work has demonstrated that experiences of social exclusion actually decreased estimations of room temperature, showing the bidirectional nature of these metaphorical connections. These findings collectively suggest that thermal conditions influence not just physical comfort, but fundamentally shape emotional experience through both physiological pathways and metaphorical associations. These embodied connections help explain why temperature metaphors for emotional states appear so consistently across diverse languages and cultures. Temperature and cognitive function. Beyond emotional effects, temperature creates significant influence on cognitive processing through mechanisms affecting alertness, attention, and specific aspects of mental performance. Research on temperature's cognitive effects reveals complex patterns varying across different types of mental activities. Meta-analyses have found that cognitive performance generally maintains stability within moderate temperature ranges, approximately 20-24 degrees, 68-75 degrees, but declined when temperatures moved outside comfort zones. Hancock et al. In 2007. However, this general pattern shows important task-specific variations. For vigilance tasks requiring sustained attention, cooler temperatures within the comfort range appear advantageous. Studies have found that performance on vigilance-type tasks improved at temperatures toward the cooler end of the comfort range, around 21 degrees, 68-70 degrees, compared to warmer alternatives, Seppänen et al., 2006. This advantage likely reflects what physiologists call mild arousal effects, slight increases in sympathetic nervous system activation that enhance alertness without creating discomfort. Conversely, creative thinking may benefit from slightly warmer conditions. Research has found that warmer temperatures, around 25 degrees, 77 degrees, enhanced creative association compared to cooler conditions, 21 degrees, 70 degrees in experimental settings, Zimmerman et al., 2014. These effects may relate to what cognitive scientists call cognitive disinhibition, reduced mental filtering that allows broader conceptual associations. Such disinhibition often facilitates creative connections between normally separated conceptual domains. Individual differences significantly moderate these temperature-cognition relationships. Research suggests that approximately 20% of the population demonstrates what thermal comfort researchers call high-temperature sensitivity, stronger physiological and psychological responses to temperature variations. Karjalainen, 2012. These individual differences create what ergonomists call person-specific thermal optima that may vary substantially across different individuals performing identical cognitive activities. These cognitive effects help explain why temperature consistently ranks among the most important environmental factors in workplace satisfaction research. Comprehensive reviews have found that thermal comfort typically showed stronger correlations with overall environmental satisfaction than other indoor environmental quality factors. This priority likely reflects temperature's multidimensional impacts on both physical comfort and cognitive functioning. Social and decision effects of temperature. Perhaps most surprisingly, temperature creates significant effects on social behavior and decision-making processes through subtle influences on judgment, interpersonal perception, and economic choices. Some of the most compelling evidence comes from behavioral economics research. Studies have found that ambient temperature influenced economic decision-making, with participants in warmer rooms, approximately 25 degrees, 77 degrees, showing greater willingness to invest in relationship-focused versus object-focused options compared to those in cooler environments, around 20 degrees south sector 68 degrees. Kolb et al., 2012. These differences emerged despite participants reporting no conscious awareness of temperature influencing their choices. Similar effects appear in risk perception and assessment. Research has found that participants in cooler environments demonstrated greater preference for certainty versus uncertain rewards compared to those in warmer settings. Huang et al., 2014. This temperature-uncertainty relationship suggests that thermal conditions may unconsciously influence fundamental aspects of risk perception, potentially through what decisions scientists call embodied cognitive appraisal, physical states influencing mental judgments. The temporal dimension of temperature experience creates additional complexity through what temperature researchers call thermal adaptation. Our responses to a given temperature depend significantly on recent thermal history, expectations, and control opportunities. These adaptation processes mean that absolute temperature matters less than relative conditions and contextual factors, highlighting the importance of temperature transitions in addition to steady-state conditions. These findings collectively demonstrate temperature's remarkable influence beyond simple comfort, affecting core aspects of psychological function through pathways rarely recognized in conventional environmental design. Temperature may be more than just a metaphor for emotional and social concepts. It may represent a fundamental dimension shaping how we perceive and interact with our social world. Creating supportive thermal environments. Understanding temperature's psychological influences allows more conscious creation of thermal environments aligned with specific psychological intentions rather than merely targeting generic comfort. Research supports several evidence-based approaches to psychologically supportive thermal design. Functional thermal zoning recognizes that different activities benefit from different temperature conditions. Research on environmental productivity indicates that spaces supporting analytical work and heightened alertness may benefit from slightly cooler conditions, around 20 to 21 degrees, 68-70 degrees, while areas supporting creative thinking and social connection may function better with slightly warmer settings, around 23-25 degrees. This differentiation supports what environmental psychologists call activity-aligned conditions that optimize thermal environments for specific psychological functions. Research on chronobiology demonstrates that optimal temperatures for sleep differ from those supporting daytime alertness, while studies show how temperature transitions support natural circadian regulation. These temporal patterns suggest the value of what thermal designers call circadian supportive programming that provides different conditions at different times rather than maintaining static temperatures regardless of natural biological rhythms. Individual control represents another crucial consideration. Reviews of thermal comfort research have found that perceived thermal control significantly enhances satisfaction independently from absolute temperature conditions. Brager et al., 2004. This control premium reflects what psychologists call environmental self-efficacy benefits, the psychological value of feeling able to modify surroundings according to personal needs. Field research has shown that environments providing temperature adjustment options typically receive higher comfort ratings than objectively identical conditions without control opportunities. Practical implementation approaches include what thermal engineers call mixed-mode systems that combine mechanical and natural ventilation strategies, microthermal zoning creating different conditions in different areas, and adaptive comfort approaches that recognize the importance of seasonal expectations and clothing adjustments in thermal satisfaction. These approaches acknowledge thermal comfort as a dynamic relationship between people and environments, rather than a fixed condition defined solely by temperature measurements. Thermal design experts argue that temperature represents not just a technical parameter, but a fundamental dimension of environmental experience with profound implications for psychological well-being. By approaching thermal design with awareness of these deeper psychological dimensions, environments can better support human flourishing through more thoughtful temperature considerations. Multisensory design principles. Beyond understanding individual sensory dimensions, creating truly supportive environments requires attention to how different sensory elements interact to create what perception researchers call unified experience, the integrated multisensory reality that constitutes your actual environmental encounter rather than isolated sensory components. The integration imperative. Your perceptual system naturally integrates information across different sensory channels to create unified environmental experiences through what neuroscientists call multisensory integration, the process whereby your brain combines input from different senses into coherent perceptual wholes. The neural basis for this integration has been well documented through research on multisensory neurons. Specific brain regions contain neurons that respond to input from multiple sensory channels simultaneously, creating responses different from what either sensory channel would produce alone. Stein, Stanford, 2008. These integration mechanisms explain why sensory experiences rarely feel fragmented despite arising from separate processing systems. Research using both neuroimaging and behavioral methods demonstrates this integration through studies showing that information from one sensory channel significantly influences how information from other channels gets processed. Experiments have demonstrated that identical sounds create different perceptual experiences depending on concurrent visual input, while identical visual stimuli are perceived differently depending on accompanying sounds. Similar cross-modal effects have been documented between touch and vision, smell and taste, and numerous other sensory combinations. These integration effects create what perceptual psychologists call emergent experiences, qualities arising from sensory combinations that cannot be predicted from individual components alone. The McGurk effect provides a classic demonstration, showing how combining mismatched visual and auditory speech information creates perception of sounds present in neither the visual nor auditory input alone. This emergence highlights why multisensory design requires considering interaction effects, rather than optimizing each sensory channel in isolation. The practical significance of this integration derives from what environmental psychologists call processing congruence advantages. The finding that environments with aligned multisensory characteristics require less neural processing while creating stronger psychological impact. Research has shown that congruent multisensory input enhances memory formation, strengthens emotional responses, and requires fewer cognitive resources compared to incongruent combinations. These advantages explain why thoughtful multisensory alignment creates more psychologically effective environments than approaches considering each sensory channel separately. Congruence and contrast. Creating psychologically supportive multisensory environments involves understanding both congruence principles, how sensory elements can mutually reinforce each other, and strategic contrast approaches that use sensory differences to create beneficial psychological distinctions. Research on sensory congruence identifies several key multisensory design principles. Semantic congruence involves alignment at the meaning level, ensuring that different sensory elements communicate complementary rather than contradictory psychological messages. Studies have demonstrated that environments where visual and olfactory elements conveyed aligned meanings created stronger psychological impact and enhanced memory formation compared to environments where different sensory dimensions sent contradictory messages. Krishna et al., 2010. This finding suggests the importance of what sensory researchers call cross-modal semantic consistency in creating coherent environmental experiences. Intensity calibration addresses appropriate balance between different sensory elements. Research on sensory marketing has documented that environments maintaining balanced sensory intensity typically create better psychological outcomes than alternatives where certain sensory dimensions dominate attention through excessive prominence. This balance allows what perception scientists call complete environmental reading, where all sensory information remains accessible rather than certain channels overwhelming others through disproportionate stimulation. Strategic contrast represents another valuable approach, particularly for marking meaningful environmental transitions. Research on architectural atmospheres documents how changes across multiple sensory dimensions simultaneously, light, sound, temperature, material, and scent shifting together, create clearer psychological boundaries than transitions where only single sensory dimensions change. These multi-channel shifts support what cognitive scientists call environmental chunking, the mental organization of spaces into meaningful units that enhances both navigation and memory. The temporal dimension adds further complexity through what researchers call sensory sequencing effects. Studies on consumer experience have shown that identical sensory elements create different psychological impacts depending on their sequence, with initial experiences creating perceptual anchoring that influences how subsequent sensory information gets interpreted. This temporal dimension highlights the importance of what designers call sensory journeys, thoughtfully choreographed sequences rather than merely appropriate static conditions. These principles have been effectively applied in various contexts. In healthcare design, research has documented how multisensory approaches incorporating congruent visual, acoustic, and tactile elements significantly improved patient outcomes compared to single-sense interventions. In retail environments, studies have demonstrated how congruent multisensory design enhanced both customer experience and purchasing behavior. These applications highlight the practical value of approaching environmental design from an integrated multisensory perspective, rather than addressing individual senses in isolation. Balancing stimulation and restoration. Creating psychologically supportive multisensory environments requires careful attention to overall stimulation levels through what environmental psychologists call arousal calibration, providing sufficient sensory engagement without creating overstimulation. Research on environmental psychology established the fundamental importance of what experts termed arousal-modifying qualities, environmental characteristics that either increase or decrease psychological activation. Studies have demonstrated that environments creating either excessive stimulation or insufficient engagement typically produce negative psychological responses compared to those maintaining moderate arousal levels appropriate to intended activities. More recent work has identified several principles supporting this arousal balancing. Stimulation zoning involves creating different areas, supporting different arousal levels rather than maintaining uniform conditions throughout environments. Research on workplace environments has found that spaces incorporating both higher stimulation zones, supporting activation and engagement, and lower stimulation zones, supporting recovery and restoration, typically receive higher satisfaction ratings than environments maintaining either consistent high or low stimulation. This differentiation recognizes what psychologists call oscillation needs, the requirement for rhythmic movement between different arousal states, rather than continuous maintenance of any single condition. Foreground-background relationships significantly influence perceived stimulation through their effects on attentional demands. Research on environmental attention has demonstrated that environments with clear attentional hierarchy, where certain elements intentionally occupy foreground awareness while others remain supportive background, typically create better psychological outcomes than environments where multiple sensory elements simultaneously compete for attention. This organization supports what attention researchers call directed attention restoration, the recovery of depleted attentional resources through environments that engage attention without demanding concentration. Temporal variation addresses changing stimulation needs throughout different times and activities. Studies on circadian psychology show that optimal stimulation levels vary throughout the day in alignment with natural alertness patterns. These findings suggest the value of what chronobiologists call circadian supportive environmental programming that provides different multisensory conditions at different times rather than maintaining consistent sensory environments regardless of changing biological rhythms. The practical implementation of these balancing principles typically involves what designers call layered sensory strategies that consider both immediate perceptual impacts and longer-term psychological effects. Successful multisensory environments often incorporate both immediately apparent welcome elements, creating positive first impressions, and more subtle, sustaining qualities that support extended occupation. This layered approach recognizes that environmental requirements change with exposure duration, allowing more sophisticated designs supporting both initial engagement and sustained psychological comfort. Implementation strategies for complex environments. Creating truly supportive multisensory environments requires practical implementation approaches addressing the complex realities of modern spaces that typically serve diverse users with different needs and preferences. Research supports several practical implementation approaches. Choice architecture represents a foundational strategy through what design researchers call accessible sensory options. Work on user-centered design emphasizes the importance of visible, intuitive adjustment opportunities for different sensory dimensions. Environments incorporating these options typically receive higher satisfaction ratings across diverse user groups compared to environments with either static conditions or complex adjustment systems requiring specialized knowledge. This approach recognizes what accessibility researchers call user capability variation, significant differences in sensory processing, preferences, and needs that no single environmental condition can optimally address. Gradient implementation involves creating what designers call sensory transition zones, rather than abrupt shifts between dramatically different conditions. Research indicates that gradual sensory transitions create better user experiences through what perception scientists call adaptation opportunity, providing sufficient time for perceptual systems to adjust to changing stimulation levels. These gradients prove particularly valuable in environments serving diverse users, allowing individuals to self-select positions within sensory continuums that best match their particular needs and preferences. Temporal sharing strategies address competing needs through what facility researchers call sequential optimization, designing spaces that transform at different times, Studies on adaptive environments show that spaces incorporating thoughtful temporal programming to create different sensory conditions at different times typically accommodate more diverse needs than spaces maintaining static conditions. This approach recognizes what accessibility specialists call temporal need distribution, the tendency for different sensory needs to predominate at different times, allowing more inclusive environments through sequential rather than simultaneous accommodation. These implementation strategies highlight the fundamentally creative challenge of multisensory design, finding approaches that respect diverse needs while maintaining coherent environmental experiences. This balance requires what designers increasingly call sensory empathy, genuine understanding of how different people experience sensory information differently based on processing variations that significantly influence environmental impact beyond personal preference alone. As architects and design theorists have argued, modern design has often privileged vision at the expense of other sensory dimensions, creating environments that may look impressive but fail to nourish our complete sensory being. By rebalancing attention across all sensory channels, including these often forgotten dimensions of smell, touch, and temperature, environments can better support human flourishing through more complete alignment with our multisensory nature. Conclusion: the sensory symphony. As we conclude our exploration of these often overlooked sensory dimensions, remember that your complete environmental experience emerges through the continuous integration of all sensory channels. Not just the dominant visual and acoustic elements that typically receive most design attention, but equally through the forgotten senses of smell, touch, and temperature that profoundly influence your psychological state through pathways both ancient and intimate. Truly supportive environments address your complete sensory being, recognizing that well-being emerges not through isolated sensory components, but through their thoughtful integration into coherent experiences aligned with fundamental psychological needs. This integrated approach transforms environmental design from merely technical specification into genuine psychological nourishment that supports your complete being through multisensory conversations that speak to both conscious and non-conscious aspects of your experience. As you continue developing greater sensory awareness, remember that perfect environments remain impossible given varied needs, practical constraints, and inevitable compromises required in most settings. The realistic goal involves creating the best available conditions within existing constraints while gradually expanding possibilities through education, advocacy, and strategic modifications, allowing environments to become active well-being resources rather than merely functional containers for activity. The journey toward more psychologically supportive sensory environments represents not just personal improvement opportunity, but potential collective shift in how we understand and create the settings of our lives. By recognizing environments as essential psychological nutrition rather than merely functional space, we open possibilities for surroundings that genuinely support human flourishing through more conscious alignment with our complete sensory nature. Your world literally touches you through these ongoing sensory conversations, through scents that trigger emotions and memories, through textures that create security and comfort, through temperatures that influence thinking and feeling, and through their continuous integration into the unified experience you call reality. When you respond to these conversations with greater awareness and intention, you transform passive sensory exposure into active psychological nourishment, supporting greater well-being across all dimensions of your being.